All right, so I want to show you the quick way for doing stoichiometric problems, okay, which is that, if you are given certain grams, then how much of product you will produce or how much of the starting material you need, okay? So here we have a problem. How many grams of lead-2 chloride is produced when 13.87 grams of lead-2 nitrate combines with hydrochloric acid to produce lead-2 chloride and nitric acid? So I gave you this equation primarily because I want us to be able to do nomenclature as well, okay? And so I want us to be able to write equations. So let's see over here, how many grams of lead-2 chloride is produced, which means lead-2 chloride. So I'm just going to write lead-2 chloride because I don't know the formula yet. Okay, I'm just writing what is being produced because, of course, I have reactants and I have products, right? So this is a product. When 13.8 grams of lead-2 nitrate combines with hydrochloric acid. So again, lead-2, remember that 2 is actually for the 2 plus, and nitrate, and there's nothing I can do about this one, right? You have to know your polyatomic ions. So lead-2 nitrate combines with hydrochloric acid. So combines with, meaning that this is also the reactant. Again, hydrochloric acid is HCl, so you need to know that as well. To produce lead-2 chloride and nitric acid. And again, nitric acid, you should know the formula for nitric acid. So now we just need to make sure we have the right compounds, okay? And so between lead-2 nitrate, this is the formula, Pb and then NO3 2, because that's what you need, 2 of these to combine with one of the lead 2 plus. And so then HCl. Here, let me erase this for a second because I need more space. So there, to give lead-2 chloride, so that's this one, and then HNO3. So now my next task, of course, is to balance the equation. And to balance the equation, the chloride, I'm looking at the product, is 2 lead-2 chloride, so I need 2 of the HCl. I also have 2 nitrate, and so of course I need 2 over here, okay? Now that our equation is written out and it's balanced, now we can see what we have and what we need. So we have 13.87 grams of lead-2 nitrate, so which means 13.87 grams of this. And how many grams of lead-2 chloride is produced? So this is what we are being asked for, okay? So that's what we are going to work on now. So here, let me just get my screen in order so I don't don't show this. Okay. Anyhow, okay. So now I need to find the molecular weight, okay, of both of these things because I need to be able to convert from moles to grams and all that, right? So here is another way of doing this quickly. So I have 1 lead, and then I have 2 of the nitrogen, and then I have 6 of oxygen, right? That's what I have. So I'm going to go ahead and find the masses from the periodic table, 207.2 plus 2 times 14 plus 6 times 16, right? That should be our molecular weight for lead nitrate, and this gives me 331.2 grams per mole. And then for lead-2 chloride, since I need the grams of this, I need the molecular weight for this as well, okay? And you need to show me all this work because, I give you credit for everything, all right? So 2, and then of course we have the chlorines, right? So I'm just writing those as well so you know how we are calculating the molecular weight. So this is 207.2 again, and then 2 times 35.45, and then this gives me 278.1 grams per mole, okay? It's nice to write units all the time, so that way you don't, go wrong anywhere. Okay, so I'm not going to do the long setup for stoichiometry here. I'm going to show you how to do this in a little bit shorter way, which I was trying to show you in class the other day. So here is what we are going to do, is we're going to start from 13 point, let me take another color, because, you have to start from 13.7 grams. There is no other way to do this, okay? So 13.87 grams. And then you're going to divide this by the molecular weight. But don't forget, in front of lead nitrate, there is no number, which means that the stoichiometric value there is 1, the coefficient, right? So I'm just going to write the 1 there just so that you know that you need to do this. If you don't do it for lead nitrate, I totally understand because obviously there is nothing there, but anyway, and write the units, okay, as much as you can. And this is, of course, lead nitrate. So write that also, that will help you. And I can see that my pen is too thick, so I'm going to make it a little bit slimmer, okay? And then multiply that by, now it's too slim, Goldilocks, isn't it? Okay, and so then now multiply that by what we have here. So now in front of lead chloride, again, the stoichiometric value is 1. So we'll put that there and then multiply that by the molecular weight, 278.1 grams per mole. Now, what this 1 really is actually 1 mole, right? Because this is the stoichiometric value. This is the stoichiometric value, which happens to be 1. But this is actually 1 mole, okay? And if you don't want to write the 1 mole, it's okay. I mean, like, don't want to write the mole, okay? You don't have to. But the 1 I would suggest you write so you remember that you need to have a stoichiometric coefficient there, okay? So now once you do the calculation, you will come up with the answer, 11.6 grams of lead chloride, okay, is formed. And so this is your final answer for this, okay? So now what I've removed here is, of course, that whole long setup and then the mole ratio and whatnot. But the mole ratio you are actually accounting for in this, okay? This is your mole ratio that you are accounting for. In this, it happens to be 1:1, so, whatever. Okay, so I'm going to do another problem now using the same equation, okay? But now we're going to just do something different, okay? So here in this one, we're going to have how many grams of hydrochloric acid are required to react with 13.87. So we're going to use the same equation. I'm just going to write it again because, it kind of went up the screen there. So we'll just write it again. So here is it, and 2HCl to give us lead 2 chloride. And then, of course, the nitric acid, so HNO3. And so how many grams of hydrochloric acid are required to react with 13.87 grams of lead nitrate? Okay, and again, the molecular mass we calculated for lead nitrate already, which was 331.28 grams per mole, right? So that was up here. So we already did that. Okay, now we need to calculate for HCl because we need the grams for that. So which means 2 hydrogen. And then, of course, we will also have 2 Cl because remember, there is 2 in front. Now you can do HCl and then multiply it by 2 also. It's up to you, okay, how you want to do this, but this is how I'm doing it. 35.45, and then you get the answer for 72.9 grams per mole. And this is the molecular weight of hydrochloric acid. Okay, so because I need to find out how many grams I need of that. Okay, so again, we have to start with what we know, what we know is the lead nitrate. So again, we have the 13 point. Okay, fine. I will go ahead and change the color. So that will help us a little bit. Okay, so 13.87 grams of lead nitrate. And then divided by, again, the 331.28 grams per mole. Now, remember again, 1 goes right here, right? And again, this is the 1 mole. Why it is? Because this is the coefficient. Generally, when you're doing all of this, you are still canceling out the units. I haven't canceled out the units because I don't want us to, okay, I'm not going to say that you shouldn't get confused, okay? Because technically it should not confuse you, right? Because when you cancel out grams and grams, and this mole is down even below, so it's another, denominator, it kind of goes up, right? But when it goes up, we also have this mole, which is going to get canceled out. So, there's a lot of canceling out happening here. So if you do the setup correctly, okay, nothing will go wrong. So again, you take the mass of what is given to you divided by the molecular weight, and don't forget also to divide by whatever molar ratio you have there, whatever stoichiometric coefficient you have. Now, for the HCl, this is going to be 2 times 72.9 grams per mole. Again, this 2 is actually moles, right? Because the coefficient here that we have is 2, but that is actually 2 moles. That's what we mean, right? 1 mole of lead nitrate combines with 2 moles of hydrochloric acid to give us 1 mole of lead chloride and 2 moles of nitric acid. That's what really it is. So again, the moles and the moles will cancel out. So you'll be left with grams at the end. Okay, that's the whole point of setting up the long way. So you get rid of your units, you understand the units, but you don't have to do it the long way. Okay, so long you set up your problem correctly. Okay, 1 grams of HCl once you do the calculation. So again, start with what is given to you, which was 13.87 grams of lead nitrate divided by the coefficient and the molar mass of that substance, multiply it by the coefficient and the mass, okay, of whatever you need, and that should give you your answer. Okay, so now I've explained this to you, in a little bit long way, but I'm going to do another problem for you in a shorter way. Okay.